Okay, so the simple example that we're going to do is just to write a program that initializes uh, arbitrary number of points in three-dimensional space, and then ultimately it writes those points to a file, and it plots the points using a simple command line tool called GNU-plot. And although this is very simple, there is a surprising number of issues that we run into that are related to the basic C programming topics that are highlighted in the notes. So the way I did this is I have version 1, 2, 3, 4, 5. Each adds a little bit more so that I can focus on just a small part of the code and add to it without having to show you everything at once, without having to live code everything as well, which can be a little bit time consuming. So let me just start with version 1, where I'm going to show you the basic data structure for the program. Okay, so in version 1, let me just say a few things. I'm using a basic text editor in Emacs. You can use Lisp to program Emacs to do all sorts of things. So for people who grew up with it like me, it's a very nice text editor. I don't necessarily recommend it for everybody, but it's just a basic text editor at its core. And the basic structure of a C program, you have to include header files that contain definitions of constants and function prototypes. So in C, functions are typed just like variables are typed, right? So just like a variable can be an int or a long or a float or a double, functions have types too, and those types are based off of their input arguments. Actually, not even their return arguments, just their input arguments. So the type and the number and the order of the input arguments. So functions have to be typed before they're called, just like variables have to be typed before they are, or they have to be typed before they're defined, just like variables have to be typed before they're assigned a value. I'll talk more about that later. But anyhow, that's what's in these header files. Okay, so if you want to use functions from the standard IO library, you have to include the header file. And of course, you also have to link at compilation time to the object code also. It's not just the header file, but the header file is necessary to be able to use the functions. Okay, so C has large standard library of functions, not as large as a modern language, but large enough that it's broken up into these different header files. The standard lib contains lots of what are considered canonical functions that are used frequently. And depending on the particular C compiler, there might be slight differences in how these things are broken up, but this is pretty standard. Okay, and I'm going to use math because I think I'm going to trying to remember what I'm taking the square root of something in this particular example. Okay, so the basic structure of the program is you start with the header files that you include. And I'm going to define an aggregate type because I mentioned what the application is that we're going to do. It shouldn't be a surprise that I define a point type. So define a structure type called struct point. Oops. All right, so this is our first aggregate type. Well, we haven't seen any types in C, but you can read in the notes about aggregate types. This is a good example. So in C, you have to call it if it's a structure. Now, there are also union types and enum types that follow the same syntax. So you have to be clear that it's a structure type. Structure type is just an aggregate of different other types. In this case, I use the built-in types float, which are typically 32-bit IEEE floating point, but the C standard does not specify that level of detail like it does in languages like Java and Python. And that's because it wants the implementation to be free to optimally use the hardware that it's targeting. Okay, so typically that will be 32-bit, but we can't depend on it. So we might at times have to use macros, which test its value if we want to write portable code. So we'll talk about that later also. Anyhow, so this is just a regular structure and it's called a struct point. And so this is the type. The type is struct point. It's a little long-winded. And struct points have 3 floats, and the field values are X, Y, and Z. Okay. Well, in C, it's typical to go an extra step and use the type def, which I talk about in the notes, in order to introduce alias for a given type. So struct point is kind of long-winded. I use the underscore because I think of it as sort of an internal type, not one that's exposed to the rest of the world. You don't have to do that. You can do whatever you want. But anyhow, I'm renaming struct point to be just point. It's a little more natural to give it a name that is just an opaque type that relates to what it is. And this is intended to represent a point in 3D space. Okay, so I'm just going to say rename struct point to just point. Okay, so from this point on, we can refer to variables of this type, or we can declare variables of this type as variables of type point. Okay, so that's pretty standard C. And oftentimes people do this all at once. So they would typically, in a regular C code, if it wasn't the class introduction, it would look like this. And that's fine. You're just doing both steps together. But since it's the first time, some of you might have seen it, or probably quite a few of you, I'll just do it in 2 different steps. Okay, so you always define your data types prior to the main program. Okay, so when I higher up in the file. All right, so now I'm going to create a program, and the entry point for a C program, just like with Java, is a function called main with arguments int char star star. Okay, so if you don't know about pointers yet from the notes, char star star is kind of like an array of strings. And that's because you want the user to be able to pass in from the Unix command line when they execute the program any number of strings that they want as input to the program. So one way to get input into a C program, very old school, is just to have command line arguments when you execute it on the Unix command line. And those arguments are captured in this argv data structure, which is like an array of strings. And this is the number of arguments that are passed in. So the 0th argument, argv0, is always just the name of the program, and the first argument's whatever you pass in first from the command line, if anything. So we'll see examples of that. All right, so this is our entry point to the C program. So I'll say entry point to all C programs. And now I'm going to use a style which I refer to in the notes as C89, which is the ANSI C standard that was it was revolutionary when it came out. It's a little primitive even by C standards and what it allows you to do. And I will, after the first homework, allow you to use C99. And I talk in the notes about some, nice conveniences in C99 compared to C89. One of them, believe it or not, is in standard strict C89. That is not a comment, okay? And C99 it is. So all my comments are going to look like this. And I know it's old school, but it's just good to know what basic C involves. And there's nothing more portable, and I guess at least for historical reasons, if nothing else. In addition to that, it's good to do it one time. So we'll stick to C89, and I'll make sure the compiler makes us stick to it. Okay, just this first program. All right, so we have our entry point. Well, now I'm going to create some variables of type point. And the way you do that is just like with any other variable. So just like you'd say int, or maybe I'd say float x. I have a problem with my L. Int j, just like you would declare variables to be of type float or to be of type int and give names associated with them. So you can now declare variables to be of type point because I've introduced a new abstract type point through this structure definition of this type def. Okay, and furthermore, while you would do it with just regular variables, point p1, p2, those are all perfectly valid. Well, I can also create an array of 4 points in this case. And why 4? Just because I'm showing you something simple to not have too many ideas come together at one time. All right, so this is an array of 4 points. Obviously, I think the array notation is pretty obvious. It turns out in C89, you can't put a variable here. This has to be what's known as a string literal, a known value. Turns out that's relaxed in C99. But in either case, we typically, if we didn't know the value 4, we would dynamically allocate the memory on a region of the memory known as the heap, which I talk about toward the end of the notes in the first class. Okay, so anyhow, we're going to introduce looping pointer I. So you might say, why not just declare I within the for loop that you're going to use it in? And that's because in strict C89, you had to declare variables at the beginning of a block, where a block is defined by an open brace. So, I mean, you could declare, you could do something like this. You have a scoping issue, though. It can only be used within this scope, but there's no glory in that. And I think it makes more sense just to declare things. It's actually, you know, not such a bad discipline to think about what you need at the beginning of the function and to keep your function short anyhow. But in C99, we can do like we do in languages like Java, and we could just declare the variable at the time at which we initialize it in the loop. But those are little details, but it's worth pointing them out once. Okay, so now we're going to set values of instances of point variables, okay, using the dereferencing operator. So just like with most languages, the you know, P0 is the first point, and .x is the value of the x field, .y is the value of the y field, and so forth. So I could just hand code instances of these point variables. Obviously, you wouldn't get very far doing it this way in a program unless you had a tiny number, but it's just to show you by illustration. Okay, so I'm going to set values of these points. I created a type, set values, and well, that's it for version 1. I just wanted to show you that much. So there's not a lot there. Most of it you're familiar with, but there's some key ideas. The idea of creating the type, declaring a variable of that type, declaring an array of variables of that type, and using the dot dereferencing operator to set the fields of that type, the entry point for the C language, and the header files. Okay, so in the next segment, we'll add a little bit more capability to our program, and we will see more examples of the things I showed you in the notes as we do that.